attribute sampling tasks. It includes some samples of questions, and it includes a brief run-through of how to use the tables for attribute sampling. There is a separate video on using the tables to solve attribute sampling examples. First, the kinds of parameters around attribute sampling. Well, first, these are always yes or no questions auditors ask about internal control compliance. Does the control operate as designed? Yes or no? The results of this kind of testing tell us whether the controls operate as designed so we can rely on them. Remember that we want to rely on controls to ensure that the transactions in all of the samples of the audit are very similar to the way the client processed all of the other transactions we did not have in the audit. These tests do not tell us if the client's accounts are misstated, only if their controls are operating. So what are the kinds of questions we could answer based on a sample of checks written against a client's payroll account? Well, the idea is to take one document and find as many different attributes that you can test as possible. Is there a signature on the check? Is the check signed by an authorized person? Is the payee on the check an authorized employee? This is supposed to be a payroll check. Does the check amount match the authorized payroll amount? Is the check written against the client's payroll checking account? Is the check written in the current year? Did the check clear in the current year? Does the check have a formal appearance? Does the check have a pre-printed number and a bank name? Is the bank account number the client's bank account number? There are many, many different attributes to be tested from one set of checks. Here are some sample questions you might answer for a set of client accounts receivable subsidiary balances. Is the customer on the approved customer list? Do the customer's terms match the approved terms? For shipping, who bears the risk of loss during shipment? Is there an interest charge for late payments? What's the credit limit? What kinds of quantities can the client buy in? Is the customer buying from an approved price list? Is the balance less than the approved credit limit? These are all yes or no questions, various attributes of the subsidiary balances. So, to set up an attribute sample, what we need is basically three numbers if we're going to do statistical sampling. If we're going to do non-statistical sampling, the auditor just picks the sample size. But if we want statistical sampling, we first need the risk of assessing control risk too low. Your textbook, Exhibit 8.4, shows the risk of assessing too low, control risk too low, as choices 5% and 10%. This risk is the chance we say the control operates as designed when it does not. Remember, if I say the control operates as designed, I'm saying control risk is low. There's low chance of control failure. The tolerable deviation rate is the failure rate of the control that the auditors can stand or tolerate and still say the control is operating just fine. It could be 0, but it's usually above 0. The expected deviation rate is how much of the time we think it will fail, and in order to do attribute sampling, we must expect the deviation rate to be below the tolerable rate. Remember that we don't do any attribute sampling for controls that we think fail. So once we have these three parameters, we can come to Exhibit 8.4 in your book. Exhibit 8.4 is divided into a top half and a bottom half, as I said. The top half, 5% risk of assessing control risk too low. Each of the columns, this row, for the tolerable rate, and the first column for the expected population rate. So each audit program or each problem must specify one of the rows And one of the columns in the intersection of the two, the number in the table, tells you the sample size. These numbers in parentheses are the number of control failures the auditor might find and declare that the control is operating as designed. Now, let's look at an example to use the table. For the sample size, sample problem, the control risk of assessing control risk too low at 5%, the tolerable deviation rate at 8, the expected deviation rate at 0.5. So we're in the right table. We're in the top half, 5% sampling risk. The tolerable error rate, 8%. The expected population error rate, 0.5%. So where those two intersect in the table, the sample size is 58. So with a sample size of 58, what we would do is get 58 checks and look at the authorized signatures. That's the attribute sample test we're setting up. So 58 checks. Now, notice that you don't have any information about how many checks were issued during the year. You don't need that. All you need to know is that there were a lot so that sampling makes sense. What comes next? We draw the 58 checks and we look at their signatures. Let's say 2 checks appear to have a problem. Well, the first thing we do is not rush off and conclude that there's a problem in the population. The first thing we do is consider whether the signatures we think are wrong are actually wrong. There's always a chance that we didn't set up the test quite right. There's always a chance we didn't know what the signature should look like. Okay, so after we've done that, let's assume now that there are 2 failures in the sample. The next thing is that in attribute sampling, the client is always interested in the sample error rate, or the number of failures divided by the total sample size. This is the number of errors divided by the sample size. Sorry, that's a little messy. In this case, 3% of the sample failed. The auditing standards say it's not adequate to use the sample error rate as being exactly the same as the population error rate. And the reason is these risks that you learned about in a separate lesson. If you say the sample rate matches the population rate, you're saying you guarantee there was no auditor error. You guarantee there was no sampling risk, as in you didn't get a lucky set of checks that just happened to not show any problems. Since you cannot guarantee that these risks are 0, we always are required to project from the sample to the population. And how we do that is by if we're doing it in a statistical way, is by using a statistical sample. If we're doing non-statistical sampling, the auditor will just decide, is 2 too many or is 2 fine out of a sample of 58 checks. Alright, then the next thing is that we're not allowed to cheat and change the parameters of the test. We can't jump up the risk of assessing control risk too low just because we found some errors. And we can't jump up the tolerable error rate just because we found some errors. So, we go into the statistical sampling table 8.6 to determine what the answer is about whether this control is working. So we found 2 errors. By the way, we're still in the 5% sampling risk table. And we started with a sample of 58. You see 58 is not in the table. The textbook author tried to save space. They go 50, 55, 60 for the sample sizes. So we're between 55 and 60. To be conservative, we'll always use the row for 55, the lower row. That means that for our test, the upper error limit will be 11.1%. So Table 8.6 gives you the upper limit on the errors, not a precise answer. The interpretation of the number 11.1 is the population failure rate for the authorized signature could be as high as 11.1%. We don't know what it is because we don't know how much similarity there is between the sample and the population. So what will we conclude? We conclude the control operates as designed if the rate that we said we could tolerate is above the rate we're projecting to the population. In our example problem, that's not the case. We said we could tolerate 8% and the upper error limit is 11.1%. And so this is the case we have for this sample problem. If the rates happen to be the same, the auditor gets to decide. That's what the auditing standards say. You decide, is the control failing or not failing? So the solution to this sample problem, we conclude this control does not operate as designed. We cannot rely on this control when designing other tests.